Hey guys, this is Kevin Smith Jr., your host for the Container Happy Hour. Grab a drink, join us every 2 weeks, and we'll talk containers and future of the market. Ladies and gentlemen, it is my pleasure to introduce you to Mr. Will Gibbs. How are you, sir?
Hey, Kevin, great. How are you?
Good, man. Thanks. Thanks for doing this episode with us.
Yeah, well, thanks for inviting me. It's been a while since I saw you guys in person down there, and yeah, this is great.
Yeah, absolutely. So this is episode 12 of the Container Happy Hour. We've got Will Gibbs from Modica, and let's start off with our drink, my friend. Cheers to you.
Hey, cheers.
Okay, so that is called a rusty nail, which was your choice. And do you want to elaborate on that? You made a few jokes on the email about why you selected that.
Yeah. Well, I can't pinpoint the moment where I decided I liked it, but um, I like whiskey, obviously, and it kind of struck me that a cocktail that has whiskey plus a liqueur made of whiskey is just like, how can you go wrong with that? And the joke part is I always joke that it's the only drink that requires a tetanus shot. Um, you know, rusty nail, but it fits also. I work a lot with metal, so spend a lot of time around rusty metal, and it just seems fitting. So I like it.
I think it was a great choice on your part. And I read a couple different recipes, and so I ended up doing one that had a little bit of a lemon zest in there, which is pretty good.
All right, that's fancy mode.
You know, this show is really top end. We don't cut any corners.
Yeah. That's great. I just go standard. I do basically 2-to-1 whiskey to Drambuie. So
Nothing wrong with that.
yep.
Nothing wrong with that. So you're coming to us from Seattle, Washington today. And tell us, I guess, just to kind of get things going, tell us what Modica is, and if you want to expand on that a little bit, how it ties into containers.
Sure. Yeah, well, without going back too far, but a little bit of background is Modica is a startup based here in Seattle. We've been running since 2018 when I started it. My personal background is in mechanical engineering, and I guess at this point, entrepreneurship. I've had a couple companies, and my previous company was involved in robotics and automation in the industrial sector. I basically helped people figure out which robots and conveyors and which systems to put together to make their product. And that is a part of how Modica came to be. The point of Modica is to make manufacturing more modular. So that means a few different things to us, but one of them um, is that when we think about building a factory, it's very common to go in with a what's called a systems integrator, what my previous business was, and do all that searching for which robots and which conveyors to use, and then how to lay them out in a factory setting. And we want to make that a little easier to do. We want to make it easier to find the equipment and then click it together. The ideal is clicking it together like Lego bricks, simplifying it quite a lot. But where the shipping containers come in is we also, in factory automation, usually start with the assumption that you've got a nice factory style building. Maybe it's a nice concrete pad and a shell over it. But that's not always the case. And so we really want to go to square one and say, if you need to build a factory or put production somewhere in the world, anywhere in the world, we don't necessarily assume that you have a nice pad already poured and a nice structure. So the shipping containers came in because it's a great starting point. It's a great unified shell. It's a great normalized and standardized form factor that can house all kinds of things. So for us, it was just a practical matter. It's the most obvious um, system that's compatible with global logistics. So it was kind of an obvious engineering choice to start with shipping containers.
So was there a preceding kind of love or fascination with containers, or it was really as simple as an engineering means to an end, this makes the most sense?
Yeah, that's a good question. I think on my part, there was definitely a bit of a fascination with it. And I think, to be honest, this is kind of a joke with most engineers, but I think it does go back to to Legos, to be honest. I even have these. These are not official Lego release, but there's a third party that makes these little Lego shipping containers. Um, they're pretty cool. But I think it goes back to that, stacking things on top of each other, like square blocks. I think there's something in my heart for that. So I was interested. But then from the engineering perspective, it does make a lot of sense.
So any truly your technology and the systems that you guys try and implement or develop could relate to any prefab portable structure, right? But it just so
Yeah,
happens that the container is dimensionally aware, strength aware, logistics aware. It kind of checks all those preliminary boxes to let you kind of expand on your piece of it, right?
exactly. It's a standardized box that exists that we don't have to engineer and make. And like I said, clearly the global logistics chain is set up for these. But it turns out that the size for it is fine. We do work with other prefab sizes. So one of our clients, we're building a prefab bathroom unit with, which sounds kind of random. It ties into our building a factory to build the bathrooms, but they're not container based. They're a different modular size, but the containers do cut through a good swath of our needs, so we stick with those. And we've become more and more container experts, but we don't hold ourselves out there as real container experts. They're just a really convenient size for us, and we just work a lot with them.
And correct me if I'm wrong, but I think I remember this from one of our visits together where the through the course of engineering and developing some ways to use containers is out of kind of a self-serving nature, you guys developed the container bot. Is that right? And
Yeah,
now that's
yeah.
kind of a marketable tool, right?
Yeah, exactly. That's kind of an interesting thing. This is something that Modica does is on our kind of core path toward making manufacturing equipment more modular and making it possible to deploy manufacturing. Um, as we build this, as we work with the containers, as we do things, we like to build our own tools. Once we have this capability of automating things, and so we use that on ourselves. And after we've discovered a pain point or something that's kind of a challenge or something that takes a lot of time, and we know we're going to repeat doing that, we started to think, hey, why don't we automate this? So ContainerBot came around because, you know, a bit in contrast to a company like EMS, we're not going to have a yard like the size of yours. We're not going to be doing that much container mod, but we do need to do a few for kind of R&D and for our own purposes. And we realized that in other areas of our production, we use water jet cutting a lot. We use laser, CNC machines, and we got coming into it from that angle. We got so used to that precision and the ability just to pop in a program file, and then the machine just cuts it. When it got down to it, and we ourselves, who aren't professionals at modifying containers, we're in there with angle grinders and sawzalls and plasma torches. Granted, we're not the pros, but we decided, why don't we kind of merge these two? And so we came up with ContainerBot, which is essentially a CNC water jet that latches onto the side of containers or sits to the side of them, and we can cut the sidewalls. And that's been something that we did for ourselves to solve a limited problem that we have. But the more we talk about it with other people, there's a little bit of interest in it as well. So
Yeah. And that's what brought us together, if I recall correctly, right?
yeah, yeah. So we reached out because, like I said, we are not nearly going to do the volume of the container production. Um, we'll end up utilizing a high number of containers, but there are other companies out there, and we reached out to you guys because we would see a company like EMS helping us do production. And wouldn't it be great if you also had a faster way to do some of these processes? So, yeah, we reached out to a few different companies. You yourself, like, so responsive and really struck up great conversations early on. So that's why we're doing this today.
Well, here we are, and I'll commend you because not only was it you reaching out directly, and I was very very fascinated with the literature that you sent over, but after one or two quick exchanges, you were you were that guy that I said, hey, maybe you just want to come see it. And you said, yep, I'll be there next week. It was kind of one of those deals. And I think we spent a solid day together kind of going through where EMS is today and some of the things that maybe you can overlap to help us. And it's still super intriguing to me as we work through this, and we're just talking openly on the show about where we are fundamentally, but we're still close to, creating that prototyping model and installing container bot for some work here at EMS and moving that along. And it's crazy to think about a container in its simplest form and it being highly manualized and the number of touches throughout its life from ships to trains and trucks and all the other dynamics, and adding something like this to it that literally is simplified and one touch file upload go.
Yep.
So that's still something that I'll be honest, I'm getting my head around,
Yep.
is the idea of implementing your technology into what we're doing. And it is nothing but exciting, I'll be honest.
Yeah. Well, I'm excited to to get it down and kind of do a pilot. We've done plenty of cutting here. Um, we just think, like I said, it for us came from a position of being really accustomed to CNC processes and wanting to just have that, one click. It's usually, it's a complicated machine, so there's some complexities, but it does simplify things. But more so than just like saving time or um, making it simpler, the advantage we found is it kind of opens up a whole new world. We're able to cut. I don't have them with me here because I'm at my home office because our shop is way too loud. But we have these samples that we cut out for folks out of the sidewalls, and we can do extremely fine detail. Anything that a water jet cutting system can do, we can achieve. So we've done little tiny pinholes, crazy curves, um, and so there's some interesting benefits that you wouldn't think about first off, but it opens up a new world of creativity. We're working with a design firm here in Seattle on some art pieces that will use container sidewalls, the corrugated pieces, and we're cutting it in such a way that when you view it from one angle, you'll sort of see one image just based on the holes, the perforations on the rise of the sides of the sidewall. And when you see it from a different angle, you'll see a slightly different view. So that was something that, because of the number of cuts, and the complexity and the size of them, would be pretty much impossible to pull off with other tools. So
Oh, completely.
beyond saving time in a business sense, there's a few other kind of interesting creative advantages that come around.
Oh, for sure. There's creativity, there's aesthetic factor that can come into play. Um, I think I have some of those images of the really precise cuts, those
Hmm.
sampling pictures, so we can kind of edit those into the episode and let people see those while they're watching this.
Yeah, great.
The I found this happened last Friday, and I didn't reach out for you to tell you because I knew we were doing this episode, and so I would just kind of drop it on you while we were talking. But
Yeah, yeah.
uh, our team was working on a project in the conference room, and they had all done all the engineering piece, they'd done all the fabrication piece, they'd done kind of all the different buckets. And I stuck my head in there to just kind of see where we were at on the bid, and they said, well, we're stuck on one part. When it's done, they want their company name carved into the sidewall of the container, and they have this really intricate logo,
Yep.
and we're not sure we can do that, on and on and on. That was the sticking point. And I said, well, guys, I think you're in luck. There is a
Yep.
way to do this sooner than later.
That's awesome. Yeah, that's perfect. That's great. I love to hear that there's a specific pain point and application for it. When we came up with ContainerBot, it was to solve our own pain, but we hadn't yet connected it with specific uses. We talked a lot. There's a lot of saying like, here's what you could do, but now, like in conversation with you, and even just now, it's starting to really get down to the specific value add for it. So that's awesome. Yeah, that's a perfect example.
Yeah, it's really good. And then I think when you were here, a scalable example, when you were here, we were working on a project that was a little over 400 units that had repetitive cuts.
Yep.
And so that idea was really exciting for us too, where you wanted them all to match each other to create a building, and the room for error was minuscule, right? So we needed them all to be synced up and collaborative in that sense. And I'm pretty sure that's when you came down to visit, is that you got to actually see that in motion, and that's when the scale model for both of us went, hang on, this is a real thing.
Right. Yep. Yeah, I remember walking through some of the units you guys were producing. Yeah, that was great. I'm glad I made that trip down. That was the first time I traveled um, by air again. I guess still during the pandemic, but that was interesting. You know, my team and I had to plan that out, and I was unsure about what the travel would be like at that point. And honestly, at that point, it was um, pretty nice. There was like nobody traveling.
It was yeah,
And at
exactly.
this point, it's back to normal and even more.
At that, I think if I recall right, like not only was your travel probably easy, but that night when we went out and had a beer and visited everything, we were probably the only ones out and about on the town, right?
Yeah, yeah, exactly. That was
So
interesting.
what other technology or, things kind of percolating in your brain are out there for containers? What other aspects do you think that'll become marketable?
Yeah, well, for us, so one of the main lines of development we're doing is something we call microfabs, and it's micro, and then FAB stands for factory automation block, and it's basically arcing toward this big vision of more modular factory equipment and factory systems. And one piece of that is grouping together. So there's this huge world of, when you think about factory equipment, of course, there's kind of big machines, press brakes and forming tools, and like kind of very large machines that you traditionally think about as factory equipment. And we'll eventually get to those, and we'll find ways to make those more modular. But where we're focusing early on is smaller format machine tools. So there's a lot of process tools like injection molding, water jet cutting, laser cutting, pretty much any like large scale industrial process or machine tool now has an equivalent smaller in granular units digital equivalent. So for example, 3D printers are one really good example. They're kind of microwave to refrigerator size depending on the technology. And then like second ops mills, small lathes, small injection molders. There's this range of machines that are kind of compact, and the microfabs that we're beginning with take that small form factor, and then we create a whole group of them. So we have basically, we line the two walls of the container inside with these small format machines, and then we have what we call a robotic interposer in between, basically a robot arm that can travel between all these machines and tend to the machines, press the start button if it needs to be manually pressed, take the parts out, put them in the next machine, put them in the QC pod, put them in the packaging pod. And that's how we make basically an entire microfactory inside the container. So you can have 3D printing to post operating, milling processes to inspection and packaging, all in one unit in a modular, sort of a recursively modular sense, because we can also stack the whole containers on top of each other. Um, but that's one where the container format is really, it's kind of shining, and we're actually starting to build the first of those microfabs this summer.
I think it goes without saying that you're pretty excited about that. I mean,
Yeah,
I think
yeah.
you were trying to contain it while you were explaining that, and it's very, very fascinating stuff. I appreciate that you brought in 3D printing, because
Hmm.
for us non-engineers, that was something that was very relatable, that I think the population at large at least has a familiarity with,
Yep.
right?
Yeah, yeah. The 3D printing is that's a heavy focus for us, or additive manufacturing generally. Those machines tend to be of the size that we're looking at initially. So again, microwave to kind of refrigerator size. So we can kind of think of them as modules, not huge monoliths. Um, and that's just an area, additive. If you haven't been involved in it, a lot of people still think 3D printers are either one of the spectrum, $10 million machines that only GE R&D has, or they're toys like the MakerBot or the kind of DIY models. And the reality, kind of state of the art right now, is there's a big spectrum, but every day there are more and more real commercial production and industrial applications of 3D printing. one of the biggest ones is in medical. So, they can do an MRI scan or a different body scan of your bone structure. And if you're getting like a hip replacement or you need to replace a damaged bone piece, they'll 3D print it in titanium um, to your specific contours of your body or your bone structure. It's just incredible. And that's one
And that's
area that
already fully available
oh,
technology?
that's already happening. That's been happening for a few years. And then there's other realms where it's picking up aerospace. The really interesting thing about additive manufacturing, in contrast to subtractive, which would be like milling and drilling and cutting a block of material, is you can achieve geometries that are completely impossible to make by any other means. You can have like cooling fins that have internal holes in them and like little channels, and you couldn't make it any other way. Some of these parts that are coming out of additive manufacturing technologies, you couldn't even make with casting techniques, which typically you can achieve more with. So that's where it really shines. And the interesting thing is, they are these processes tend to be slow. Additive is, it's a layer by layer thing, or it's a slow iterative process generally. There are techniques for parallelizing. You can build a whole bunch of parts that have nested in a cluster to kind of improve your time, but it's still very slow. So our insight is, as these machines become more, there are more of them, and as they become cheaper, the strategy for achieving volume is to just have more of them. You just have many more sort of small format machines, and you run them all in parallel. And instead of having to make one machine faster, you can have 100 slower machines producing the same volume, and you get some redundancy. So
And we
that's one.
containerize the whole thing.
Containerize the whole thing. Yep, whether it's in containers or some other modular structure, but containers actually work great for it right now. Um, the other aspect that it plays really well, especially in the additive realm, is a lot of these machines kind of require not necessarily a clean room environment, but they kind of want a certain context. You're not just going to put some sorts of 3D printers out in your open shop floor, like next to the welding shop. Like they want some, they want heat. They have like thermal considerations. They have HVAC considerations where the power goes. And so the great thing about working with the containers as a superstructure is we create our own little environment. We create our own little
Right.
perfect setting, and you can actually have one group of 3D printers that maybe all want to be at one temperature or have one sort of air environment or cleanliness level, and then another group, and you can actually create these rooms, um, for those without having to build it out with traditional, architectural elements, which can get expensive and it's fairly
Sure.
inflexible.
And I mean, that kind of plays into why the container has become the application now for, say, Bitcoin mining
Yep, yep,
and grow houses,
yep,
and to try and, create some segues into other industries that people are super familiar with. You're seeing more and more of those develop into a containerized model. Not only is it the compatibility with the modular structure, right? But I think it's also something that maybe doesn't go to the naked eye, is that thermal integrity, right? And your ability to kind of control a temperature, control an environment around this modular entity, right?
right.
And so that's where the application, where we see it end, your guess is as good as mine, right? Like
Yeah,
containers
exactly.
still have this unknown potential.
Yeah, yeah, it's kind of amazing. I'd encourage anybody to read. There's a book, The Box. I have it on my shelf out here. That's
Yeah, I do
kind of
too,
the history of
actually.
the shipping container, and of course,
Yep.
I'm super interested in it. But it's kind of amazing to think, this is all coming around um, decades and decades ago, and we're still discovering new uses for this form factor. We made a box, it's a steel box that you can do. It radically changed transport, obviously, but now we're finding other reasons that standardization like that can improve production and making interesting spaces for all kinds of new technologies.
Oh, absolutely. And just when we do kind of a cursory view of our client base and our collaborative groups that we're engaged with, it's funny to look at 10 years ago, 5 years ago, current. and the diversity of who we're working with today, as opposed to 10 years ago when it was shippers, freight forwarders, NVOCCs, export driven traffic, maybe a little bit of oil and gas. And then you watch that progression to today, and it really is. It's everyone from people like yourself through the Bitcoin, through the grow houses, through the tiny home movement, and it's become that piece far more than it has the export driven logistics transport that it was primary focus intended, right?
Right, right.
And that's and I have no crystal ball, but I would suggest to you that's going to continue.
Yeah, yeah. I'm in agreement. Yeah, and it's interesting to see. I've of course working with containers. I think I only have a sliver of the view on this that you would have, but kind of getting a grip on container what the container means within the global economy and what signals it gives for kind of understanding the health of trade. And it's been interesting to see kind of you don't think about it, right? I don't, when I talk to
No.
people about shipping containers, um, you don't often consider that these are transporting a lot of our goods overseas, and also, the reverse is happening. We're building stuff here and sending it out. But it's kind of this blind spot. You just think things show up on a store shelf, and of course the pandemic has really made it very clear with supply shortages. But I've been thinking a lot about containers and how that market is um, moved. From my less than 10,000 foot view, and like that you would have, especially with the volume. But interesting to see how that works out.
I think that's a great observation on your point, and obviously you're an analytical enough guy to say, how do these data points kind of begin to allow us to project availability and price models and all these ancillary factors, right? And the funny thing is, not only is the supply chain broken, and we've seen that accelerated now more than ever, but we're also seeing that the topics we're talking about today, the secondary market, the secondary application, right? Where anytime a container is used not for its primary function of transporting goods on a vessel, right? Anytime it's absorbed into that secondary market, you're having to deplete the overall stock, right?
Hmm.
So there's this fascinating economic supply and demand curve that isn't just a traditional access point, right? Because it's getting a lot of influence from other aspects. So I don't think we have the true access point yet. And
Right.
that's where it's very interesting too. And so you're talking to people outside the container industry where you and I might have a chat one day and talk about all these factors, and you ask questions that I don't get in the course of my day just talking to container people, right? Because you're bringing this fresh set of eyes on it. It's truly fascinating, I promise. So I have to ask this because people are going to watch this and then they're going to go find you on LinkedIn, which is a good thing.
Yep. Yep.
And it declares on your LinkedIn that you are a pan industrialist, right?
Yep. Yep.
So for us lowly container folk, explain that in layman's terms. What does that mean?
Yeah, that's a great question. And to be frank, I am borrowing that. We'll say that term really struck me, and where it comes from is it's actually a book by a professor at Dartmouth. His name is Richard D'Avenant, and he has a book called The Rise of the Pan Industrials, and it's a business book. It's kind of uh, this expert in the academic side of manufacturing and understanding manufacturing within the global world economy. It's his view on the future and how uh, the future really is companies, at least in the manufacturing space, who are capable of uh, basically becoming more vertically stacked, basically being able to provide more services internally, support more processes internally, and have basically more arms. It's kind of like the future is these like micro conglomerates is kind of the theory, I guess. And it struck me because I admittedly am a generalist. The joke with mechanical engineers is they're jacks of all trades, masters of none, and I do find that to be true. Because my dream would be I love making things personally. I love making things on behalf of my company, and I love making things through the company. And uh, I would be involved in virtually every type of production process, and I want to be involved in every factory. And like I have that personal interest, and we're kind of arcing Modica toward being adaptable enough to address needs within so many different areas of industry. But yeah, it really struck me. The pan industrialist, the pan prefix would just mean across many. So with Modica as an example, we are not focusing on any one specific industry. We're trying to find the commonalities in how we build these modular factories, how we build a micro factory in a shipping container for different types of industries and different applications instead of focusing on one. We'll see if that is the correct strategy. I think building a broader base works for us, but that's where it comes from. And it's a great book too. It's not just, it's really great, I think, for anybody who's interested in kind of like where manufacturing is going. And it's kind of data based on, how large companies in the past that sort of lost their competitive edge due to failure to spend on R&D and failure to broaden their base. I think that's a pretty common story, and he reinforces
Hmm.
that with also focusing a lot on additive. I would say one fault of the book is maybe it's over focused on additive manufacturing. I don't believe that additive is going to supplant every kind of fabrication.
Right.
It's like, are you going to 3D print a whole container? Probably not. So yeah, it has its limitations, but that's where that piece comes from. And it's a little, I don't know, maybe I haven't earned that yet, but it's my aspiration.
No, it's good. It's good, and it's I thought it was worth bringing up because I figured it was some kind of personal target there. So that was good.
Yeah.
So before we kind of wrap things up, do you want to let people know how to find your site, find your social, kind of just give us a quick rundown of where updates would come?
Yeah, definitely. So we're on LinkedIn. You can find us Modica Micro Industries. That's Modica, and we're pretty easy to find. We're one of the top results. But then, we're not quite as active yet, but we do have Twitter and Instagram. We're made by Modica in each of those venues. And I'm a super available person in terms of communication. So find me on LinkedIn. My email is will@mmicroindustries.com as well. Feel free to reach out.
And I can reiterate that fact that it is directly you talking. You're very responsive and you're eager to kind of chat up different theories and philosophies on this stuff. So
Yeah, yeah,
I uh, I think this is incredible info. I'm kind of sitting in that situation right now where I'm gonna have to listen to this 10 times and make sure I understood everything you were saying properly. But I also know that our new in-house engineer Connor is gonna lose it over this episode. He's gonna be a big fan.
that's
So
awesome.
I appreciate you doing this, buddy. Thank you very much for doing Container Happy Hour with us.
Yeah, was so glad to join, and yeah, I'm looking forward to many more great conversations and projects together.
Yeah, we're gonna do it, man. Have a great rest of your day.
Awesome, you too.
Thanks, brother. See
Take
you.
care.